Hey y'all, welcome back to another video. Today we are going to be talking about a physical or chemical change. Please make sure you get the appropriate header up across the top. We've got 5.2. Is it a physical or is it a chemical change, and how can we tell the difference? So let's jump right into it. So we're going to jump right into what a physical change is. And a physical change is one that shows a change. Wow, that's pretty in appearance. We should probably change that out. We don't want that one. All right, but change in appearance. Let's go with the pen there. All right, so we're going to say a change in appearance. So it looks different, but it is still the same material. All right, or substance, right? So nothing changed there. We have the same substance there. All right, we have the same substance. All right. Nothing changed about it. Okay, change in appearance looks maybe different, but it's still the same thing. A chemical change then is we have a new substance formed, and this is going to be our biggest focus this unit is we are looking at that new substance formed. What we do, this chemical change can also be called a chemical reaction. And that's going to be our focus. Chemical reactions, if you think about it, is the name of this unit. All right. So let's talk about the things that are physical changes, and then we'll talk about what is a chemical change. The big one that's a physical change are phase changes. These are like changes in state. Changes in state. For example, when water or when the snow outside melts, right? Snow melting, still water, right? We have snow, which is made of water mainly, right? We're not talking about the impurities and stuff in there. But when the snow melts, we get water. So it's ice to water, still water, the same chemical formula, it's still H2O. Some other things that you can think of for physical changes are if something breaks, if it splits, if we grind it, if we cut it, if we crush it. Notice that we're not forming anything new. We're just changing the appearance just a little bit. Can you think of any others? If you can, go ahead and add them down below. Awesome. Let's go to a chemical change. So, a chemical change, there are kind of four main things that are an evidence or evidence of a chemical change. One of those is a transfer of energy. Does it get hot or does it get cold? All right. So, change in energy is like a change in temp. And let's kind of go a little deeper into that and say kind of unexpected, right? Unexpected. If I pull an ice pack out of the freezer and put it on my leg is going to get cold, right? But that is expected. But if I put baking soda and water and then that water gets cold, that is unexpected. So that is typically sometimes a chemical change, right? Depending on how you want to define it, but probably the baking soda and water is not the best example because we can get it back, but we'll go from there. Now, another one is a change in color. And again, I encourage you to think about an unexpected change in color. This is unexpected. All right, because if I put food coloring in water, that is technically a physical change because I'm just adding food coloring to the water. I'm dyeing the water. If I put green food coloring in, I'm going to get a green solution. I expected that color change. If I put two chemicals together that were initially clear and it comes out pink or something, then I'm like, oh, that's a chemical change. Okay. Another one is the production of gas. This one can be perfectly exemplified with our baking soda and vinegar. We put baking soda and vinegar together, we get gas, right? This last one is formation of a precipitate. Remember, a precipitate is an insoluble solid. Insoluble solid means that it doesn't dissolve. Insoluble means does not dissolve. So we are forming a solid that does not dissolve. One of the perfect examples of this is when we take lead 2 nitrate and we add it to potassium iodide. When we put those two things together, we get an insoluble solid and it's bright yellow. We get a bright yellow solid of PbI2 or lead 2 iodide. So these things can happen multiple times. You could have just one, or you could have multiple of them kind of all together. Okay, awesome. Let's hopefully see that we have this kind of all figured out. And let's just go through my breakfast. I ate eggs for breakfast this morning. So we have cracking an egg. So I crack the egg. What has happened? Have I changed anything? Is it still an egg? It is still an egg. So we would say that this is a physical change. All right. This one is a physical change, right? No change in the egg. We still have the egg. All right. Now, cooking an egg. Cooking an egg. So I throw it in the frying pan and I cook it. Is that different? Is the egg different somehow? Does it taste different? Like a raw egg versus a cooked egg? Absolutely. So this is going to be a chemical change because we have an all new, right, substance, right? I definitely don't want to eat a raw egg, but a cooked egg, I'm pretty okay with for the most part. I prefer it like on a McDonald's McGriddle, but I digress. Okay, so let's finish this. When I'm done digesting my eggs for breakfast, ooh, not that we want to talk about that, but that is a chemical change as well because we are converting that egg to energy and protein and getting all those calories from it so I can go ahead and teach or whatever I need to do. All right, so hopefully this is fairly simple stuff. Um, Next up will be your homework, and I'll see you next time.